life science people. Today I'm talking to you about simple invertebrates. So what I want you to do is, if you can, don't worry if you can't, because I know sometimes that you can't see two screens at the same time, like watch the video and look at the book at the same time. But if you can, I want you to turn to page 380 and go along with me, okay? So, yeah, sorry, got distracted for a second. So simple invertebrates. So humans have them, snakes have them, but octopuses and butterflies don't. What are they? It's a backbone, okay? So animals that don't have backbones are invertebrates. And that's about 96% of all animal species. So it's actually more rare to have a backbone than to not have one. So we talked about this before about symmetry. So there's radial symmetry, there's bilateral symmetry, and there's just asymmetry. Bilateral is because I can like split myself in half and I'm about the same on both sides. I'm not exact, but because we're not all completely symmetrical. This is one reason why when you look in the mirror, you might not actually recognize yourself. Like from a picture, you look different from the mirror because mirrors are flipped. And so you don't actually see yourself except for in a picture. Now that sounds really weird, but that's what's happening. And so sometimes you're like, I don't look like that, do I? Well, you do to everybody else, but to yourself, you see yourself in the mirror, which is flipped. But for the most part, we are down the middle. We are bilateral. Bi meaning like bicycle, two. Lateral meaning like basically sides. Symmetrical, okay? Other ones have radial symmetry, like your echinoderms, like your sea stars and your, oh goodness, I forgot all of a sudden, your sea stars and your anemones and other creatures that have a radial symmetry, which means if I split it, more like a pizza, if I take out a few pieces of the pizza, I can still cut that thing into slices all the way around. Then there's asymmetrical, which is like all crazy, like sponges, okay? Those of you who presented sponges, you know what I'm talking about, okay? So those are the body plans of of invertebrates. Now we are vertebrates, obviously, and so we can be bilateral, but there are bilateral inverts as well. Okay, one of the things that they have is they have animals, except sponges, have special tissues that make fibers called neurons, and neurons are like your brain cells. Okay, they are the cells that carry information across one part of your body to another part of your body. And in invertebrates, they have often these nerve cords. Okay. And these nerve cords are, well, they're cords of nerves. I mean, pretty self-explanatory. But sometimes they have these bundles of nerves. It's called a ganglion. And you may know from like Finding Nemo, there is a part where Mr. Ray, the teacher, says, keep your circumesophageal ganglion to yourself. He may say supraesophageal ganglion. It's very similar. But what it is actually, it made me laugh so hard when I heard it because I just thought it was hysterical, because I know what a supraesophageal ganglion is, and I know what a circumesophageal ganglion is. Supra is a big bundle of cells that's above the esophagus. Circumesophageal ganglion is a bundle of cells that goes around the esophagus. Both of which are basically like tiny little brains that control the body, control senses, help you organize the senses. So that's what it's a mass of nerve cells. Got something animal out back there making some noise, weird noise. Anyway, guts is our next one. Guts. All right, so almost all animals digest food in a gut. And a gut is a pouch lined with cells that release chemicals that break down food into small particles. Our gut is like our stomach, and our stomach is actually way up high. And then, of course, there's our intestines that actually break down food as well. But every creature has some kind of situation like that, or most creatures do, that break things down. And they break them down so that the nutrients can be easily gotten to. If y'all remember, when we've talked about erosion in the past, when a big rock gets broken down into pieces, it's easier for those little pieces to break down further. Think about ice. If you have a big block of ice, it takes a long time to melt, but if you break it up into little pieces, it takes a shorter amount of time to melt. And that's what your body's doing. That's what your teeth are doing. It's chopping these things down so they can get smaller and smaller so that your body can absorb the nutrients. So in complex animals, we have what's called a coelom. Coelom. A coelom. And it's a body cavity that surrounds the gut. So, earthworms have this, as you can see in your book. And it helps so that the food and everything doesn't disturb, and movements in there don't disturb the rest of the body. And I keep on referring to us, even though we're not invertebrates, but it'd be weird if, like, you ate something and it would just go into your whole body. Instead, it just stays in your esophagus and in your stomach and so on. So there's a coelom situation. And with earthworms, it's the same. You have a coelom. So those are the basics. Tomorrow, we're going to go into some of the examples, like sponges and, let's see, looking at your book, sponges and flatworms, cnidarians, and roundworms. So we're going to go into that on tomorrow, okay? So we're going to spend 2 days on these simple things because they're not as simple as you think that they are. It's not as simple as people like them to be portrayed as. I mean, because actually, if I have the right tool for the job, my job is simpler. It's easy to do. If I don't have all the tools, it's harder to do. So these creatures are doing what we do, except for with a lot less tools. So a lot fewer tools. So it's pretty cool. I think these things are incredibly cool. So we'll talk about more of them tomorrow. So have a good day.